When a function call occurs, arguments are passed to parameters. And the way that we're able to write function calls relative to a function's definitions depends on an agreement between arguments and parameters. So in this video, we're going to take a look at the details of parameter passing. Parameters allow functions to tell anyone who wants to use this function, hey, here are the pieces of information I need in order for me to do my job, right? And so we see that when we define a function, after the name, there's some parentheses, and then inside those parentheses, we give a parameter list. And those parameters are going to specify both the names of the parameters, and those names are important inside of the function itself. It turns out that the names of parameters don't really matter outside, other than as a hint as to what data you expect to be given to this particular parameter as an argument. And also the types. And the types are actually what's most important. The number of values in the parameter list as well as their types are what, when you want to go and use a function, you really need to know and make sure you get right. So in this example, if we define a function named max2, where we have two parameters defined, you can see them. X is an integer parameter and Y is an integer parameter as well, and they're separated by a comma. And so by defining these two integer parameters, we're saying these are the two things that max2 the function needs in order for you to be able to use it. And if you want to use this function, you've got to give it these two things. These look a lot like variable declarations. It looks like we're declaring two variables named X and Y, because we actually are in a special way. And I'll come back to this intuition in just a moment. These variables are local, meaning they're contained within the function call or the function block. And we'll see what this means in terms of the implications in memory when we get to looking at memory diagrams. But the idea is we can have many different functions that have parameters named X and Y, and that's okay because those names are going to be specifically resolved to, or specifically they will mean the names of the parameters of that individual function, and they're separate from one another. So if two functions share the same parameter names, their values are still separate and unrelated to one another. So what effect does declaring these parameters actually have? So we have this max2 function, it takes two integers. Well, when we declare this, we're saying in order to use me, you've got to give me these two things, right? You've got to give me these two integer values. And so in this case, if we look at these three example function calls, we see in the first one, we've got the function call is the name of the function followed by parentheses, right? And notice there's no def keyword in front of this. So that's one of the ways that you can tell whether or not you're looking at a definition of a function or a function call which uses some other definition of the function. And so we see this name followed by parentheses, and then inside of it we see two values. And these are our arguments, right? And we'll talk about arguments in just a second, but notice that specifically we have one that is an integer, the first one is an integer, and the second one is an integer, right? And so that corresponds to the first parameter and the second parameter, and that checks out. We've got an agreement between the number of arguments we're trying to give to our parameters as well as their types. Well, if we try and call max2 with only a single integer, notice there's a disagreement here. We aren't providing both values that are needed for max2 to do its job. And so this would be an incorrect function call, and this would lead to an error. Similarly, if we have three integer arguments that we're trying to use with this max2 function call, it wouldn't work because only two of these parameters are defined on this function definition, okay? So the distinction between arguments and parameters can be a little bit fuzzy as you're first getting started with programming. It's important to recognize that parameters are what we're defining inside of the function itself, and arguments are what we give anytime we call it, right? And so the arguments wind up being values we assign to parameters in the process of making a function call. And we're going to dig into that idea very directly in just a moment. As we just said, the types must also match. So if we had tried calling max2 with two str values or two string values, notice max2 with a string O and no, we would see that there's an error because this function definition tells us you need to give me two int values. You can't give me two string values, right? So we're trying to set up a contract or some sort of agreement that if you want to make use of this function, that's great, but you've got to fulfill my needs and you can do so by providing me the arguments that I need for my parameters. You've got to give me the information that I need in order for me to be able to do my job. You've got to give me the things I need to work. That's what we're trying to specify with our parameter list. All right, so let's dive in to the actual step-by-step. And I want to give a preview of a memory diagram that we're going to be looking at in full depth in one of the very next videos. So before we even get into this, what we're going to say is when we make a function call, so imagine that we are at some line, and I'm specifying the line number in our program file, line 1 here, and we make a call in that line somewhere to max2 with the arguments 8 and 9. Well, one of the first steps that we'll see in setting up a memory diagram is we're going to set up some space for that function call's variables to live. And we're going to keep track of where did this function call occur, because remember, when a function call happens, we jump to the function definition and then we go right back to where we came from. So we need to keep track of where are we coming from, and that's going to be the RA we'll talk about in more depth in just a moment, but it means return address. This is where we're going to return back to with some returned result value. All right, so each time a function call occurs, there's a sequence of steps that happen in order to get into that function. And so we're going to break them down in much more detail here. First, is the name bound to an actual function definition, right? So here we see the name of this function call, max2, and we're going to look up, is there a definition for that function call? Is there a function defined with the name max2? And sure enough, there is right here, right? So that checks out. The next thing that's going to happen, and I should say that if there wasn't one, if you tried to call a function that hadn't been defined yet, you'll get a name undefined error. And you'll have some sense that, oh, I'm trying to call a function before it was defined, or I accidentally mistyped my function name. All right. Does it have the correct number of parameters? Yes, it does. 2 parameters. So we need to match in both the number of parameters, and we also need to evaluate our arguments. So here we have 2 argument literal, or 2 int literals, so there's no real evaluation to be done. But this could have been, we could have used the variables x and y if we had int variables who were named x and y, and those expressions would be evaluated down to whatever value they are. And those values need to match, right? So the int values of these 2 expressions, which are just number literals, match with the int of our parameter list, all right? So then that's when we're actually going to go and set up this stack memory, which we talked about before, and we'll be on our way. Right? So next what happens once we've set up some stack memory is there needs to be a process for what we call passing our parameters in. Right? So we're taking our arguments and we're passing them to be parameters. What does that mean? Behind the scenes, it's as if when we evaluate the parameter passing step of this function call, it's as if the interpreter of our programs is saying, okay, we're going to assign x8, which was the first argument, right? This was the first argument that corresponds to x. So we're going to assign x a value of 8, and we're going to initialize x to be 8. And we're going to do the same with y. We're going to initialize y to be 9. And so this step happens invisibly. You will never see these 2 lines of code in your program, but the effect of calling a function with 2 arguments like this is that before the function is evaluated, those 2 parameters are assigned to those 2 matching argument values. If there were 3 arguments and 3 parameters, the same thing would apply. We would have an extra parameter being initialized. So the first thing that happens in a function call is we're initializing these parameters based on the argument values. In our memory diagrams, you'll see that we're going to set up some space and say x is 8 and y is 9, and now we've initialized those variables in memory, right? So this is parameter passing, and this is the step that I think can be the most perplexing because you never actually see this occur. You can only see the effects of this occurring, right? But behind the scenes, this is how I want you to visualize and try and imagine what happens each time a function is called. And notice that if we called this with 10, 9, then this would be x is initialized to 10 when this function call occurs, right? So one of the nice things about function definitions is we can pass in any values we want for these parameters as long as the types match. All right, so then we jump into the function body, and after those parameters are initialized, right? So these steps are done, that's when we would start evaluating our function body, right? So now we can ask, is x greater than y? Well, we look up in memory, we see x is 8, 8 greater than 9, that's false, right? So this would evaluate to false in this particular function call. It won't always be false, but this time around it is. So that means that we're going to jump to this else block, right? And so we'll do that next. So when we go to the else, we hit a return statement. And what does a return statement do? Well, we evaluate the expression here. So we evaluate return y, and we look up y in our frame, that's 9, so return 9. And what we're going to do when we start diagramming this is we're going to indicate the return value of this function call is 9, and we're going to send this value 9 back to where this function call occurred, up on the return address of line 1. So this function call would evaluate to 9. When this expression, this function call expression is evaluated, its result would be 9, right? So that's parameter passing. And the big idea is we need to be careful to be sure that the number of arguments correspond to the number of parameters and that the ordering of their types also match. You need that alignment. It's an agreement. You can think of like a contractual agreement. And then when a function call occurs, we take those argument values. We have to evaluate them first. We need singular values. We need to know what the actual values we're passing to our parameters are. Those arguments get passed over and assigned to our parameters. So those parameters are initialized, and then the function call continues from there. In the next video, we'll look at the return statement a little bit more closely because it has some peculiar behaviors that we need to understand in order to fully understand how function calls work.